Okay, everybody. Um, Hope the week was well and last lecture was interesting for you guys. I was really happy to see some of the commentary going on. I hope that continues. I actually want to cover some of them if you all don't mind. Um, so I want to go over some of these Slack questions and the discussion. So I'll start with the earliest posting, which was Elise, and then kind of just move through and just give my take or answer any questions or call out some interesting things that I saw. And then we'll get into the actual lecture. So on Elise's description of her accident, it was really interesting, Elise, how you explained, in particular, the pilot's various training deficiencies, and also the note about SFO, which correct me if I'm wrong, but I think that's San Francisco, which I've been at. That is a strange airport for sure. Um, and it really makes you think, right? At what point do pilots trainings done? Because how many airports are there, and how can we expect pilots to be super familiar with every different one and what you have to do to approach it? But it is interesting, and I especially the fire truck thing was odd. That's quite strange that that happened, but I guess I'm glad the fire truck didn't do that. And yeah, changes to pilot training, with the review of the design of the automated systems. That's usually what you'll see a lot of times is in accident investigations. If they don't typically have, if the organization doesn't typically have like the stomach or is interested in any kind of broader reforms, training is like the default. It's the new human error, since it's kind of gotten around that, if you assume human error is the problem, then you're not doing your job well enough. They say, okay, it's training. So, which is an interesting question, right? Because um, it's assuming that all these people are trained to some level. One of the biggest things about getting your pilot's license is being able to, I mean, that's why you get instrument rated and stuff so that you can understand the plane that you're flying and how to perform some of these maneuvers. So that's one of the things that's always interesting to me is how are we not training them? And more importantly, if they are trained and they want to do a good job, what got in the way? And that's what's important to consider. Um, so at least you might want to consider, for example, um, some of the pilot's perception about the automations and some of those things, are those barriers, are those things that should have been in place and weren't or failed due to some glitch or software issue. So start kind of considering it within that frame. And as you're reading through these things, try to identify in your head just what the causal factors are, what the barriers are, etc. But yeah, really good. Going down, we've got Jamie's. Okay. Oh, 737 Max. So at the INL here, we've actually done some work on the 737 Max. I'm not totally sure how we got involved with it, but especially from a risk assessment understanding, um, it's been something that we've done a fair amount of. One of my colleagues has done a couple papers and has kind of become like our 737 Max expert. Um, yeah, so the issue with the autopilot, this is an interesting thing. So there is with the 737 Max, they put in a new automated safety function that adjusts for angle of attack, which is obviously the relative angle relative to the ground that you are flying the plane at. Because at certain angles of attack, it was found that the airplane could stall. And so what this system was intended to do is to prevent some of these extreme angle of attacks, or is it angles of attack? I don't know. To see, to manage that so we don't get the plane stalling. The problem with at least one of them, so the 737 Max in particular, there were two main flights. This is one. There was also, so this was, I think, Jamie, you're doing Ethiopia, right? Yeah, there was another one, which I want to say was Thailand or Malaysia, Southeast Asia, I think. And I know for a fact on one of them, essentially this autopilot or this angle of attacks system is managed by two sensors. On this particular plane, one of the sensors wasn't there for some reason, so it's relying on a single point failure, and that one sensor was broken and was not repaired. So the angle of attack situation was actually, I mean, we could say it was performing as expected given its relative data inputs. It was getting very bad data and all those things. There's also a very interesting discussion on this about crew overload. So, for example, during the again, I'll have to look if you're interested. Let me know, and I'll dig up one of the papers by Zachary Spielman is his name. He wrote a paper on the 737 Max, and one of the two planes, I don't think it was Ethiopia, I think it was the other one. The crew, the co-pilot received in 11 minutes, they received 11 messages from the air traffic control, 11 new headings, and he was trying to take direction from the pilot. At the time, the pilot was getting yoke vibration alerts, which is when the actual steering column of the plane will vibrate to kind of identify that. Meanwhile, the cabin's all going crazy too. So you get to a sense of wondering, okay, in this accident, how well are we designing our accident situations? How well is how well are all these systems supporting our pilots during an accident? And that's a big question there. So yeah, one on each side of the plane. Yep, you covered that one. So was it an issue with the 737? So when this happened, these were the only two big accidents. And it generally can come down to potentially a safety culture or a funding thing about these two flights. So I can't remember which airline, but there was airlines in the US that were flying 737 Maxes. So, and there were reports of this issue, but there kind of is an argument or an acceptance to maybe our planes are maintained better or more frequently. So, and our training may be better in those instances. And that's kind of what's important here. But the angle of attack autopilot thing, I mean, it controls the plane. So a lot of these pilots, apparently to turn it off was quite the ordeal. Like you have to go deep into a menu somewhere or something. And so a lot of pilots were fighting it. So you've got pilots pulling up on their stick while the plane's forcing them down in those instances. So those reports did happen in American Airlines too, but and other, more industrialized nations, but there wasn't an accident except for these two. But so it is a problem with the 737 Max. It was overly sensitive, and there's different. I mean, we're still waiting for some of the bigger reports on this, but they've obviously grounded all of them worldwide, and then they've been trying to fix it ever since. I know there was an article recently about the 737 Max that are flying again, and some of those things were corrected. So Todd, this is a great comment. The size of Boeing, were regulatory agencies hesitant to investigate them. So with the 737 Max, one thing that's been pretty common across government is just due to funding concerns or other things, is most of the federal agencies are understaffed, whether it's the FDA or the IRS. We only hear stories about how, there was a news story where they only audit poor people because rich people, it takes too long and it takes too much manpower and they don't have that much. So a lot of those agencies are understaffed. That includes the FAA. So this is an interesting situation where Boeing was actually allowed a special dispensation to regulate itself. So this system was able to be validated by Boeing representatives with some cursory oversight by the FAA, which is obviously a huge problem and will likely not ever happen again. But that is, I don't know if they were hesitant to investigate them or more just couldn't. And they probably would have been hesitant because then it makes them look bad because people are going to ask, why didn't you guys do it, right? Then Shane, okay, Exxon Valdez version 1. Yeah, so this is an interesting thing. When they made contact with the reef, the chief engineer thought it was one of the turbochargers. I've always wondered with these giant ships, like, are they too big? Are they too big and there aren't enough sensors? There's not enough information flow about what's going on with these things, which is something I've always wondered. I don't know enough, I guess. Let's see. And then Derek, okay, we got Exxon Valdez part 2. All right. Okay, clarifying who was in control. So this is one of those instances where you want to make sure your accident investigation really tracks the sequence of events well and understands who's in command when, and is that normal? Was that person's normal shift, or was there changes to the schedule, etc.? That's one of the things that I'm wondering if they covered. Yeah, and Todd, was there, or what was the reason there was no bearing change? That's an interesting thing. So a lot of these huge ships to turn takes miles and miles and miles, which I wonder if that was an instance. But yeah, that'll be interesting to see the answer there. And then we got Todd. Okay, Deepwater Horizon. Yeah, cost-saving decisions and risk assessment. So this is the interesting thing, right? This is kind of the paradox of it all. So the reason why cost-saving decisions are made is because there's not been a sufficient reason beforehand to demonstrate a need for more expensive safety measures. So what usually will happen is there's a high level of regulation or a high level of safety expectations. And over time, as the industry or the equipment, whatever it is, performs safely, oh, we don't need this anymore. Look, we haven't had this accident and those kind of things. Remember, humans frequently underestimate any kind of future risk. We are not great at that anyway. So, and especially if our own self-interest is involved. If you're an executive and you might make it a bonus because you cut costs or whatever, this is one of those things to look at. It's kind of easy picking. The problem is, and we talked about this with resilience and fragility. So over time, and one could argue, is the reason you haven't had issues because you've had all those expensive safety-ish instances, because that's the problem, right? You can't prove a negative, and or prove a negative, and then so if you haven't, you can't investigate things that didn't happen to try to see what their cause was. Is the reason that it didn't have an incident or whatever because this barrier was in place or whatever. You can't do that. So it's a lot of kind of gut feeling, trying to make the best of the data. And yeah, you don't necessarily want to overprotect. It's a balance there. But as you start to throw out some of these safety systems or safety things, essentially what you're doing is you're making your system more fragile. You're hollowing it out, is the way I've always thought of it. So that's one of my things there is, yeah, if this was interesting, Derek, you comment, if you're given 2 options for safety measures, which ideally wouldn't ever have to be used and both keep you safe, of course, you'll choose the less expensive one. How do we know they both keep you safe if they're never used? That's also the other question. So for everybody's evidence information, in nuclear, there's a whole subset of risk assessment called probabilistic risk assessment, which are essentially people that build statistical and probabilistic models to essentially run hundreds of thousands of simulations of various accident sequences, and they include all of the equipment in the plant, so that they can essentially say, okay, if we break this one thing, what happens downstream of the plant? And that's how we in nuclear try to assess risk and what's the likelihood. So in nuclear, you have what are called, when you get licensed by the NRC to perform, you are saying that the risk of a beyond design basis accident or event, BDB, is of some low number. I think it's like once in every 10,000 years or something is the way it works out. But I work on human reliability analysis, which is like the human side of PRA, but I don't do enough with PRA, honestly. And so you're essentially saying, okay, we might have one of these every so often, because you're never going to have a zero. That's not possible. So when we're looking at that, that's kind of our standard here in nuclear. And beyond design basis, just so you all know, this is something that came about after like 3 Mile Island and such, which is nuclear reactors are designed with certain failures in mind. They're designed to be able to experience some pretty dramatic and traumatic things to the equipment. But there are instances that are beyond the design of the reactor that can happen. One of those would be like a core meltdown or those kind of things. We think of long-term power outages. Fukushima, great one. Huge tsunami. Acts of God are generally considered beyond design basis events. So with some reason, seismic engineering and that is still important, but that's one of those questions, right? Nuclear does that. But nuclear is also heinously expensive, generally because of regulatory requirements. So that's one of those kind of questions you run into. But that's always my question. How do you know something keeps you safe if you never use it? And what kind of data are we relying on for that? And that's the trick. Okay, and that was all those. So we will start in on this lecture. Sorry, I yammered a little bit there. Okay, don't know why that's there. That's going to annoy me. Anyway, so 7 steps of accident investigation continued. So we went through securing and documenting the scene before. Now we're going into conducting interviews. Sorry, this is a little bit blurry, but it's one of my favorite memes ever. Why do you want this job? I've always been passionate about not starving to death. Conducting interviews will be the most difficult part of the investigation. It's also the most critical and valuable. And the most important thing to remember during this is to prepare. So when you're planning on making a good interview and setting up a good kind of process, preparation is key. So you need to know the 5 W's: who, what, when, where, why, and then your how for your interview process and your goals. You need to set the tone, establish trust and rapport. Remember, something bad happened and that's why you're involved. So people are naturally going to think that you are trying to get them fired. Questioning process. So this is where you have to have a plan for the interview and know your question strategy. So there's an old saying in law school, a good lawyer never asks a question they don't know the answer to. This is very much like that. Some of your follow-on questions, you won't know what those are, but essentially you need to have an answer in mind for every question they're going to give you, or flip that around. You need to have an answer in mind for every question you're going to ask. And that doesn't mean they can't deviate from it, but it's really important to kind of know what you expect. And you'll revise that as you go through your interviews, as you get more and more information, okay, why did X happen? Well, you've already heard some other people and collected evidence, etc. You have an idea. And if they say something different, you note that for a follow-up to say, hey, so, some of the other information I've gotten says this should have happened, but you're saying it was something different. Can you explain that a little bit more? And then you're closing. So you always ask for follow-up information or additional contacts. The additional contacts is one of the best things. Like I've said before in previous lectures, asking somebody, hey, is there somebody else we should talk to, puts them into a place of expertise, shows that you're admitting some lack of knowledge and helps kind of build that rapport as well. It's also necessary. We're not going to get anywhere if we're just going down a list given to us by management. And then reestablish the tone. So this is, you essentially reestablish the tone you set during the opening. As you prepare for the interview, remember this is the most important section of all of this. So you'll need to sketch a timeline of the incident using available information. So all of your evidence, any information you've already gotten, documents, procedures, etc., will enable you to understand kind of the rough timeline. You'll develop a list of interviewees and your list of questions. Now, this next bullet where you develop an error-free scenario, this is really important as you go down the road for change analysis. So you need to have an understanding via procedures, information, or system SMEs or anything of, okay, what's the perfect way to do this? What's the best way you could possibly perform this task? And then you compare what happened and everybody's feedback of what happened to that point. And it's essentially, we're just asking, where did it all go wrong? All right, some things to remember. You need to focus fighting bias. In particular, we all have various biases and we have cognitive biases, the way our brain works and things. You have to actively fight against those. But more importantly, make sure to not be biased in terms of the situation and the scenario. So what will almost always happen if an investigation is undergoing and one of the people thinks they know what happened. Oh, I know why this happened. What your brain does, even if it's unconscious, is it starts to find facts to affirm that. That's our confirmation bias, versus trying to find what happened through the facts. And it's important. That's, there's an old quote, I think it's Sherlock Holmes, facts to suit theories instead of the other way around, because you should be trying to find out what happened given the facts, not trying to find the right facts that fit in your bin. Keep the proper perspective. So this is an important question. A lot of people will say, why did this event happen? The real question is, why did we let it happen? Why did on the 737 MAX airline, why did we let the maintenance lack on that or slack on that plane? That's how you're going to get at the root cause, not just why did it happen. And these are some of the key questions that you need to be able to answer. Essentially, what happened? Why wasn't it perceived before it occurred? And why didn't we stop it? And now what do we do? So problem statements. I know when I went through my cause analysis training, this is a hard thing. So in particular, don't get predisposed to the cause and trying to determine the problem. So I'll give you kind of a framework of how to write a problem statement, but the cause really it has no place in it there. You need to precisely define the problem you want to prevent. And if you can do that concisely and accurately, you're halfway to the answer. A good problem statement is a huge foundational step up for your overall investigation. And this next one, word problems are hard for a reason. So this is the problem statement kind of challenge. We're not very good. I don't know if you all remember, always remember grade school math and word problems and those things. There's a reason that it's hard, because our brains crave context and explanatory facts. Our word problems almost never given to us. And we need the why and other aspects of whatever the problem's trying to ask us. A problem statement does not have those by design. It is not designed to get bogged down by these kind of details that are superfluous for its use, but it makes it hard to write. So creating a quality problem statement is the foundation of the entire analysis section you're going to go through. some more information about this. So you need a single concise problem statement that identifies the issue, state the object and the deviation, and your details within your problem statement should be when, what, the object, the deviation, and the consequence specifically. And I'll give you an example in a minute here. Some big things to not have in your problem statement. There's no whys in a problem statement. There are no potential corrective actions. You should identify effects and consequences and the severity of the problem and those consequences. You need to ensure that the problem statement contains only one problem and condition, and use it to maintain focus throughout the investigation. Remember, this is going to be your North Star, your guiding principle. So here's an example of a problem statement. I'll give you guys a second to read that. Okay. So what do we get? A loose fuse caused a pump to alarm and then a pump to go down. A couple things. We need to understand the impacts and effects of this situation. So is the effect of this that it caused an alarm? Does that matter? Probably not. What matters is that it was declared inoperable. That's the thing that's the problem. It's supposed to, it's supposed to do this. So that's not the problem. And then as per technical specification, et cetera, and what's required of this, we're getting close to this corrective action situation where we're proposing some of these situations or recommendations. That is not necessary either. So if we clean this out and simplify it, this is what we get. And that's your problem statement. So at all times, you're trying to answer questions around this problem statement. Like I said, if you can get this part down, it is one of the most important parts of your overall cause analysis. And as you get to some of the techniques and methods that we'll use. I found this is kind of an interesting, if it helps you kind of build in the timeline and some things and when they'll be there. So this is based off of NRC guidelines. So this is your draft report has to be done in 30 days and your final has to be done in 45. Your specific areas may change that timeline, or if you have specific regulations. So we're looking at interim actions and extent of condition. These are your first steps. You need to put this thing in a safe condition or fix whatever's broken so we don't have any other immediate issues. And you're going to do an extent of condition to see if you need to take interim actions on anything else. This is like the 737 MAX. Okay, is this all the planes or what do we know? Initial data gathering, interviews, analysis, report prep. You're in a conclusion, you're going to start working on your CA. This is your corrective action plan. And then the CDI expectation is 60 days. CDI is a reference to a regulatory document. I can't totally remember what that acronym is. But throughout that, we're collecting evidence till about 2 weeks. We're analyzing the facts and report writing the entire time as we're working through this. And that's important to note there. Okay, when we develop a sequence of events, we need to understand the order of the events. It needs to be logical, fact-based, focus on the cause and not blame. An adequate sequence of events won't say Bill incorrectly drove this. That's a blame. That's not the cause. Bill was tired and therefore drove incorrectly in this instance. Okay, now we're getting closer to a cause. You're trying to understand the characteristics of an event. You have the actor versus action conversation. So who did what? Or what did what in the instance of like an equipment malfunction or an piece of equipment doing what it's supposed to, but just the situations made that a problem. We've talked before about systems causation. So one of the challenges is the sequence of events. So in systems causation, we said, everything has a place, everything has a part of this. And if that's true, then causation gets really messy and tricky to manage. So it's important to kind of keep that in mind as you're doing this. If this is hard or seems like, oh, it could really fit a couple different ways, that's because it can. So you always go back to your problem statement. You always look back at your timeline, your sketches, and think, okay, which one best explains the situation is, and try to align that as best you can. Next step is the conduct surface and root cause analysis. So we'll go into each of these tools later, but barrier analysis, change analysis, event and causal factor charting, extent of, etc., which is cause and condition. Then task analysis. Task analysis isn't necessarily a defined subset of root cause analysis, but it's something you're going to end up needing to do anyway. So this is when we talk about an error-free scenario, you want to understand how a task analysis is specifically focused on human performance. So you want to understand how is the human supposed to perform these actions. There are different types of task analysis. We'll probably touch on them briefly later, where we'll talk about tabular versus hierarchical and what their benefits are and how deep you really need to go. But what you might see, even if you're doing a task analysis of the perfect scenario, you might start to see what we would call error traps or error precursors, different things that, okay, we're asking them to do this and it's not something that they're going to probably be successful with, etc. That's a huge part of root cause analysis, so that you can, again, just like with change analysis, we're wondering what changed from the perfect instance. With the task analysis, it's similar. We want to know what part of the task failed, and that will tell us some more about the human performance in the motion. Next up, determine solutions. This is effective corrective action plans, which we will go into shortly about what makes a good corrective action versus a bad one. There needs to be clear linkage between the cause and the corrective action. Every cause has a corrective action, and every corrective action is tied to a cause. One thing I want you all to kind of be aware of as you're reading your reports, everybody picked, these are very public events. There are almost certainly corrective actions that are not tied to a cause. And I just want you to ask why. Is this we have to do this to save face, etc.? What's going on there? Because that is incorrect. There should always be that loop. Your corrective action should not make things worse. So unintended consequences, really kind of be thoughtful about those. Your corrective action plan needs to include the intent of your actions. You need to have a way to document the corrective actions. And then you need to develop interim corrective actions. So let's say one of your corrective actions is a large scale change. It's going to take a year to really complete. Okay, well, in the meantime, we have to make sure this accident doesn't happen again. So what are some maybe more acute actions we can take, or strong actions in the short term, to mitigate it until this is all corrected? And then consider the risk to repeat recurrence during the completion of the overall action plan. That's what we're talking about with interim corrective actions. We want to make sure that while we're executing all these corrective actions, we're doing whatever we need to, this is you're going to tape off the area until it's done kind of thing. And the last step, write the report. So no matter what, you have to consider dissemination. Who's going to read this? Who's your audience? What's the tone and circumstances of the report? Understanding the overall goals. And your report must reflect accuracy and not bias or politics, especially like organizational politics and those kind of things. The accident investigation report is to protect people and property from harm. That is the priority. is to be able to give that information to the team or the organization or the broader community, the public, so that we can all get better. That's the goal. And it can be a challenge depending on what pressures you may be under. I guarantee you some of the folks with the 737 MAX, there was probably a ton of pressure on some of those people. But it's important that we keep our eye on that focus, that on explaining what went wrong and being honest about that is more important than trying to hide things or mitigate stock price falling or those kind of things. And we are now through all of the steps. So this week and next, so for next week's lecture, we'll be getting more into causal theory and human error, some design solutions, and just kind of some of these concepts there. If any of these jump out as particularly interesting, put a post up or shoot me a note or something. They're all kind of interesting topics to me. No one seemed to have an issue there. So your report and or slides, October 8th. I haven't totally decided. I think I'm just going to have you guys do slides unless somebody really wants to do the report and doesn't want to do slides. Either way, you're going to post either into the Slack. You can post both slides and documents. I actually have had students in the past, they'll record their PowerPoints and put it up. That also seems to work in Slack, but obviously it would probably depend on the size. So I would say if you're thinking about those two and trying to prepare, think more on the slide side of things. It's just a little bit more approachable. And plus, let's be honest, your report, if I had you do that, you're going to write the report and you're going to dice it up and make those slides out of the report anyway. So I don't mind that. And I had some questions about like what that looks like. I'll have like, maybe I'll make up a fake incident and show you guys just kind of a quick explainer about the accident investigation of that to kind of give you guys a reference. And keep in mind, it's your chance to educate the class on your event and the investigation and some critiques. What would you do differently? What do you see? Maybe you see a cause that you think is more important. And we'll keep that in mind. After we're all through that, we're going to be in corrective action space, which is similar to problem statements. They're really hard to write. So we'll have some interesting conversations about that as well. But as you're going through these events, and especially as you're discussing on your posts, consider these things. Okay, did an accident focus more on cause or blame? What corrective actions did they put in place, and did they work? Were they tied to causes or not really? Those are kind of those questions I want you to be considering. And I think that's about it. So I will chat with you guys on Slack, and great job last week.